तो चलिए सोल्व करते हैं आज का लीट कोड क्वेश्चन। आज है अपने पे फाइंड द लेक्सिकोग्राफिकली स्मॉलेस्ट वैलिड सीक्वेंस। दिखने से खतरनाक लग रहा है। ओके, सो लेट्स सी व्हाट डू वी हैव गिवन टू स्ट्रिंग्स वर्ड 1 वर्ड 2। ओके, एंड string x is almost equal if one exactly matches. Okay, most, oh sorry, a string is almost equal to y if we can change at most one character in x and make it identical to y, basically, right? After one change, if we can make it equal to y. Okay, sequence of is valid if ascending order and result equal to word 2. Okay, okay, okay. So the question says you're given a word 1 which is for v b c c a. You're given word 2, right, which is a b c. Now from this you have to choose a subsequence, right? Such that, right, let's say if I choose some b, I choose some a, then something, some 0 1 2, right, these index, right, such that the characters is these index equivalent to this word 2 after one change, right? One change is allowed, one mismatch. That means you say that VBC, right? Now VBC is not equal to ABC, but we can change this V to A, right? That is one change is allowed. So this is what the question says. Okay. Hmm. Constraints are till 3 into 1 e raised to power 5. So we have to do this in of n or like n log n, but we can't do it in n square or something. We'll see which one of these is correct. But if we want to solve this question, what we are going to do? See, okay, let's see one, let's do one dry run and think. So let's take this above example, or let's take the second one example. Huh? Word one is word B A C D C, and word two, right? Word two is what? A B C. Okay. Now see, if let's say if I'm at some index B and I'm at index, we'll call them I, and we are going to call this J. See, if I'm at index I, right, then is this equal? No. So which, like, what I have to choose to make this equal, right? C matches, right? This B we can't take because then we cannot have a in the left side, right? And this A we can take and this we can replace. So we can have A replace C, right? And we can replace anyone from C and D. And which one we are going to replace, right? C, right? Greedily replace. Now, how? See, at any, if we want to do this, right, what question we need to answer, right? See, if let's say this matches, right? A matches. See, B does not equals to A, but this A, right? These two A are equal. So what I have to answer, right? If I choose this, right? If I choose this I, right, right, then from this, what do we say, this CDC, right, this position, right, that is I plus 1 to n, right? Can I form this BC, right, whatever is left, right? Can I form this J plus 1 to m, right? This we have to answer. This is the important part. See, if I choose this character I, now from the whatever's in the right side, right, can I form the right side of word 2? And what is allowed? One mismatch. Okay, one mismatch is allowed. Now see, if I am at a position I and I have to tell how many match in the right side, what is the best way? So we prepare a suffix array, right? Suffix array. Okay. Now, suffix array we need. Let's say we prepare a suffix array, right? Of the above, right? What will be the suffix array? So C matches with 1. The suffix array will prepare for word 2, right? Because in word 2 we have to tell. See, can I form this one, right? J plus 1 m. So we have to form for word 1, right? Now this, as this index C matches 1, 1, 1, 2. Okay. So this is like 1 matches 1, 1, 2, because at this place, right, C equals to C, at this place A equals to A, right? Now this will also be 2. So this is my suffix array. Okay, now we have the answer, right? In the right side, how many are present? Now we have to form a valid sequence about it, right, we have to form a valid sequence. Okay, so that means, right, this is our word 2, which is A B C, and this is our word 1, which was for B A C D C, right? B A C D C. Now see, so let's say this is I, again I, and this is J, right? Now, at any index, right? At any index, what do I have, right? See, either we are right s of I, this t of j. Okay, these are right word one. Okay, let's say this one says yes, this one says like string target basically. Word one word is confusing, but okay, let's say this s and t. If this is equal, right, then we can always pick this, right? Since it's greedy, always pick right because the next index, right, I plus one will always be greater than I, right? So that is not give us a lexicographically small solution. Okay, so what we are going to do, we just do j plus plus. Okay, now if these are not equal, right? If right, if s of I not equals to t of j, right? Then now see, if these are not equal, right? How many characters we have remaining? Remaining is m minus j, right? M is what? Length of word two, right? How many are remaining, right? Okay, now among this remaining, see, if one mismatch is allowed, right? If I pick this current one, right? So there's this choice, right? Pick I, right? If we pick I, then left to match equals to what? Remaining minus one, right? See, remaining minus one, I still need to match, right? Okay. If these are still need to match, then what? Uh, okay. If these are still left to match, then what do we check, right? If what, right? If our suffix array, right? If suffix array of I plus one, right? Whatever is at the next of suffix array, right? Can I still get this remaining minus one characters out of it, right? See, at any index I, if it does not match, that means how many I still have to match? Remaining minus one. If I pick this current one, and if I have this much to match, they should come from suffix, right? If this is true, what do we do? We matched one, right? We matched one basically, okay. And what? This is we matched, we exhausted, and this we go j plus plus, right? So that's it basically, right? So whatever it is, if this is true, right? Add I to answer. If this is true, again add this I to answer. Now just that's it basically. Okay. Okay, so in the end, there was like, what are the parts of the question? Simple, right? Parts are what? First is prepare suffix array. First is prepare suffix array. Part two, right? If we choose, right? If we choose s of I, right? Then there were two cases, right? Either this s of I equals to t of I, right? Or right, this is s of I not equals to t of I. If this is equal, see, so sorry, t of j, right? If this is equal, just simply do, right? We move to next, add I, right? Now, if this is not equal, right? If this is not equal, right? Then what? Then still we have two cases, right? Match remaining, right? Match remaining or not. See, if there is a match remaining, what does it mean? It means I can do one mismatch, right? So what we are going to check, see, is my suffix, right? Is my suffix of I plus one, right? That is from word one of I plus one to n minus one. Can I form what? Word two of j plus one to m minus one. See, this suffix one of minus should be greater than what? What is left, right? Left is what? M minus whatever is my j minus one. That's it. Simple, simple. Just not nothing complicated, nothing much. Okay. So what is the time complexity, right? Suffix array we prepare in O of n. This is kind of two pointers approach, right? This works in O of n plus m. Okay. Yeah, that's it. So I'll paste the link for the solution of the lead code in the comments. But first try to solve this question by yourself, right? Then it's fine. Thank you. So let me add this one.